These are your quadratic application notes for day 1. In front of you, you should have 2 papers. There's a gold calculator hint sheet, and there's also a blue worksheet that has all of our problems on it. If you take a look at the gold sheet, this is the sheet that you should reference while you're doing your homework. It gives you some steps through the problems. It gives you some hints on the problems, wording hints, calculator hints, and tips and buttons that you should also press. So if I'm looking at the gold sheet right now, it says step 1, read the entire problem and write an ordered pair based on the context and units provided. If I go to my worksheet, problem number 1 says Jason throws a ball to his friend Eileen. The ball leaves his hand 5 feet above the ground and has an initial vertical velocity of 50 feet per second. The throw is modeled by h of t equals negative 16t squared plus 50t plus 5. So if I'm trying to identify the values, this problem doesn't explicitly tell me what x and y are, but I know that in the equation, I'm normally going to see x where t shows up. And so if I think logically about this, t is going to stand for the time the object is in the air. And I know that y shows up on the left side of the equal to symbol. So if I see h of t, h stands for the height of the ball. If I go back to my gold hint sheet, step 2 says determine a good window for your graph. So I'm going to go to my y equals, and I'm going to enter the equation, negative 16. We're going to use x instead of t squared plus 50x plus 5. Verify that's the correct equation. I'm going to go to my window, and there's 2 ways I can approach this. I can think about it logically and reason through it, or I can also do it mathematically. So logically, if I go to my paper, we said x stands for the time the object is in the air. If I think about it, it doesn't really make sense to have a negative time. So a lot of the times we're going to set the x minimum to 0. There are some times where you'll want to see the part of the graph that's to the left of the y-axis. So some negative numbers might also be appropriate. Not every graph goes through 0, 0 in the real world. So either 0, some negative numbers are appropriate for that x minimum. If I think about the problem, we're throwing a ball from one person to another. I don't think the ball is going to be in the air that long. If you can imagine throwing a ball to your friend, maybe about 5 seconds is kind of my guess. And if I'm counting from negative 5 to 5, I'm going to count by ones. So going back to my notes here, the y value is the height of the ball. So a height is not going to be negative. I'm going to start at 0. Again, if you want to put some negative numbers in there to see underneath the x-axis, that's totally fine. We could change this to like negative 5, your choice. If I think about the height of the ball, I don't really know how high it's going to go. Let's make an educated guess of maybe 50. If I'm counting from negative 5 to 50, I'd like to count by 5s. So this is my window if I make an educated guess and kind of think through it logically. But if you flip your gold paper over, on the back, it actually shows you how to mathematically find a good window. So step number 1 is type the equation into y1. We already did that. Step 2 says use your table to find the vertex. So what I want to do first, it says put the table setup into ask mode. And in order to do that, I'm going to type second and then window. And I get this screen right here. I want to be able to enter the x value myself. That's the independent variable. So I'm going to switch this to ask. Next week when you go to take your test, if you don't change it back to auto, numbers will not show up in your table. But for right now, that's what I want. So I hit second graph, and you'll notice your table is now empty. Step 2 says to go to, part B, go to the table. So second graph, we did that, it's empty, and enter the x coordinate of the vertex. And by now you should know the formula negative b over 2a. So if I apply my equation and the a, b, and c values that show up there to negative b over 2a, I have negative 50 divided by, you'll need to put parentheses, 2 times a is negative 16. And those all came from the equation that's in problem number 1. If I hit enter, it's going to give me the x and y values of the vertex. So 1.5625, comma 44.063 is my vertex. What that means, the vertex is about halfway through the graph. So if the x value is at approximately 1.5, I can double that and I get 3. And my prediction is that it's going to come back down and hit the x-axis somewhere around the number 3. If I go back to my window, I predicted the y maximum of 5, so it's probably a pretty good guess. If I go back to the table, my y value is 44.063, and so that will tell me the maximum value. That's the top of my graph. Keep in mind, if I go back to the hint sheet right here, the parabola is either going to open up or down. Since this one has a negative leading coefficient, I'm looking at the parabola that opens down. So my vertex is at the top, the maximum is at about 44, and I had predicted, 50 as my y max. So I'm guessing this is a pretty good window. If I hit graph and it doesn't look that good, I can come back and fix it. Here's my graph. Not too bad. Again, I probably don't need all that space to the left. Maybe I'm going to go and adjust my x minimum to maybe like -2 instead of -5. And what I like is that this graph is pretty big. It takes up most of the screen. I can see the vertex. I can see the x and y intercepts. So I'm very happy with this window. I'm going to go and copy it down. We went from -2 to 5 and counted by ones, and then -5 to 50 and counted by fives. So part A says, what is the y-intercept? By now, you should know that the y-intercept happens when the x value is 0. If I go to my equation and I plug 0 in for t, I should be left with the constant, since this equation is in standard form. So my y-intercept is 0, 5. The question says, what does this represent? Because we're not actually going to say, what's the y-intercept? We're going to ask you in context of the problem. So if I go back, 0 is the x-coordinate. That's the time the object is in the air. And 5 is the y-coordinate, the height of the ball. Well, if the time is 0, that's the initial starting point of the ball. That means we haven't started the stopwatch yet, and that's where the ball is going to be as it leaves Jason's hand. So the ball is 5 feet in the air as it leaves Jason's hand. Part B says, how long does it take the ball to reach the maximum height? When you read that, really focus on some key words. This one is the maximum. To me, that hints a vertex. If you go back to your gold sheet, there are some wording hints. Anytime you see maximum or minimum or maybe even highest or lowest, that means you're going to look for the vertex. And the good news is we already found the vertex. We know that it was at 1.56, let's see, 25, comma 44.063. And the question says how long. That refers to a time, and time is my x value. So the answer I'm looking for is 1.56. The directions at the top of the paper say to round to the nearest hundredth, and time is measured in seconds. Part C says, what is the maximum height the ball reaches? Again, keyword is maximum, so I'm looking for a vertex. We already have the vertex that's written down in Part B. This question's asking for the maximum height. If I go over, my y value is the height. So this question is asking for the y value in the vertex, which is 44.06, and the height is measured in feet. Part D says, Eileen catches the ball when it falls to a height of 3 feet. About how long is the ball in the air? We're given the information of 3 feet. That is a height, and so that's a y value. what we did is we're asking you to find a random point on the graph that has a y value of 3 feet. So if I go to my calculator, because it's a y value, I'm going to hit the y equals button. And in y2, I'm going to type in the number 3. What I'm doing is I'm creating a system of a parabola and a line because I have a quadratic equation and a linear equation. If I go back to the graph, you can see the system of two equations. And what I want to find when I'm solving a system is an intersection point. So I'm going to hit second trace, and number 5 is intersect. It says first curve, and my cursor's on the blue curve. I hit enter. The question says second curve. Now my cursor's on the red, so I hit enter again. And when it says guess, you hit enter a third time. Now the problem is it found the intersection point that's over on the left, and that's not going to work for me because the time is negative, and in our context, negative time doesn't make sense. So I'm going to do it again, second trace, select number 5, and I'm going to take my cursor and I'm going to move it over closer to the other intersection. Your calculator is going to find the intersection point that your cursor is closer to. And my calculator's pretty slow, so I've hit the cursor too many times, which actually isn't a big deal. It's still closer to the intersection point on the right. I just didn't intend for it to go off the screen. So I hit enter, it'll jump to the line, I hit enter, and then I hit enter one more time, and it finds the intersection of 3.16, comma 3. So the y value is 3, that's what we want, that's the height of the ball. The question's asking for how long. That tells me I want to give the x value, which is 3.16, and time is measured in seconds. And we move on to problem number 2, and we repeat this process. It says the arch of the Gateshead Millennium Bridge forms a parabola with equation y equals negative 0.016 times the quantity x minus 52.5 squared plus 45, where x is the horizontal distance in meters from the arch's left end, and y is the distance in meters from the ground. So this one explicitly tells me that x is the horizontal distance, and y is the vertical distance, because it's the distance from the ground, which is also the same thing as the height. So I'm going to go to my calculator, and in y equals, I'm going to type in negative 0.16 times x minus 52.5 in parentheses squared plus 45. Now this equation is different than the one that we just worked with. The first one was in standard form, but this one's in vertex form. So I actually know the vertex of this one is 52.5, comma 45, without actually doing any of the work. We take the opposite of the number in the parentheses and the same as the number outside. So when I go to set my window, let's clear out y2 also. I can start at -2 again. My x value of the vertex was 52.5. If I double that, I get 105. So I'm going to go a little bit bigger. Let's go to 110. And I'm going to need to change my scale to something like tens if I'm counting from -2 to 110. My y minimum's fine. If you want to change it to 0, you can. The y value of the vertex was 45, so 50 will probably work for me. I'm going to hit graph. I'm pretty happy with this graph. I can see the x, the y-intercepts, the vertex, everything's there. It's big on the screen, really easy to read. So I'll go copy down my window. -2 to 110, we count it by tens. -5 to 50, and we count it by tens. Oh, we count by fives on that last one. Part A says, what is the height of the arch of the bridge? So you need to interpret this now. If I go to my graph and I put a ruler to this graph and I wanted to measure the height, I would be looking for the distance from the x-intercept up to the highest point, which we know is the vertex. If I'm looking for the vertex, we know the height already because the y value tells me the vertical distance or the height, and that's 45 feet. Part B says, what is the width of the arch? So again, let's go to our picture. If I'm looking for the width, the widest part of this graph is going to be at the bottom of the parabola. And considering the x-axis is kind of like the ground in our problem, I want to measure the distance between the x-intercept on the left and the x-intercept on the right. So to find x-intercepts, I'm going to go to second trace, and number 2 is 0. 0 is another way of saying x-intercept or solution. And the question says left bound, so I have to take my cursor and I've got to get it over to the left of one of the x-intercepts. I'm going to go find the x-intercept that's over on the left first. It looks like it's pretty close to 0, 0, but I don't think it's exactly 0, 0. So I'm working my way over there. It doesn't matter what number your cursor is at, but it needs to be somewhere to the left of that x-intercept. So right now I'm going past it over to the left. I can go off the screen, it doesn't matter. I'm going to select this point right here because it's to the left of the x-intercept. And then it says, what's the right bound? So I go over to the right of it. Again, numbers are not important, but right now you can see that that x-intercept is between the two dashed lines. And so I'm going to hit enter one more time, and it tells me negative 0.53 comma 0. And again, if I'm looking for the width, I need to find the two x-intercepts and find a distance. So now I'm going to go find the second y-intercept. I'm going to try and jump over, ooh, our window moved, hold on. Let's go put that back. You can probably scroll over pretty quickly on your calculator using the left and right arrows. You saw in the problem before, mine takes a while. So I'm going to hit trace and type in 100. Make my cursor jump over closer to that other x-intercept on the right. So second trace, I select 0. My cursor is currently to the left of the x-intercept, so I'm going to hit enter. I move over past it, I go to the right of it. I hit enter, and my x-intercept is between those two arrows or the dashed lines that's there, so I'm happy. I'm going to hit enter one more time. It says 105.53. In geometry, your teachers should have taught you to find a distance. You're going to subtract the two values. So I'm going to take the bigger number and subtract, be careful, there's a double negative here, the smaller number. And that should give me 106.06. Measuring a horizontal distance, oops. Actually, both of these are not in feet. They are measured in meters. So again, if you have any questions, these are going to get tricky once you get home and try to work on them on your own. Please use the gold sheet for reference. The top half on the front will give you some key words to look at. The bottom half is all of the keys to press on the calculator when you're trying to find key features. And then the part on the back will help you with the window.